Good morning, dear students. In today's lecture, we will study how to find a delay using register pair in 8085 and by using nested loop. So previously we had discussed how to find a delay using register pair using single loop. Like I am again repeating that previous one lecture, then we'll continue with the nested loop. Like what we had discussed, for example, if we have a one of the counter, like suppose D is my counter, I'm taking here the maximum counter. It may be FFFFH, or maybe in decimal, it may be 65535. So for this, we need to decrement the counter. We have to use DCXD. And as we have discussed in the previous video, like JNJ does not work upon DCX. So we have to take this value. We have a counter D, this value as a D, and this value may be stored in E. So whenever we have to decrement the counter, we have to make a concept of OR operation to check whether this value becomes 0. So we have to move this value into accumulator. So we can move this any of one of the value to the accumulator, because we can perform this operation of OR instructions or any logical instruction. One of the input should be in accumulator. So we have moved one value into the accumulator, and after that we can perform the OR operation, like we have performed the OR operation with D. So after that J and Z will work, because J and Z only work upon 8-bit instructions. So we have to do this by using OR operation. We can check whether this counter will become 0 or not. So after doing this loop, it will become the label here and it will decrement the counter, which we have already discussed in the previous video. So in this case, if firstly, how to find the total number of T states in this case, like we have in LXID, this we know 10 T states. For this, we need 60 states. And for this, we need 40 state. And for this 40 states, again for this 10 T states or maybe the 70 states. So this is the one of the loop. And whenever we need to find a total number of T states in this loop, so this is a method. Like firstly, we need to write the number of T states inside the loop. Like what is the way to write here? That 6 plus 4, that we have to write in this way: 60 plus 40 plus 40 plus 10T multiplied by 65535. 65535. Then after that, we need to reduce 3 T states, because one time 3 T states would be less. And outside the loop, there may be 10 T states. So we have to calculate these T states, that it may approximately equivalent to 1572847 T states. So if you have now in this, we are discussing the inner loop, like there may be the nested for loop. So for this case, we have to use another one counter. So we are taking one counter of LXI. Again, I am taking the one more counter, LXI, for example, B, as a maximum value in hexadecimal. It may be 65535 in the decimal. So again, I have to decrement this counter. So where I can decrement here, I have, this is my inner loop, and for 65535, this loop would be executed 65535 times. So I have to again decrement this loop, that may be DCXB. Then again, the same concept we use, like we need to move some of the value from this, like one of the value may be moved to B and one of the value may be moved to C. So what thing we need to take here, we have to move one value can be moved to the accumulator. After that, we can perform the OR operation, like OR with like one of the value in A. So we can perform the OR operation with the P. Then after that, again, we have to check whether this value became 0 or not, counter. So we have to do J and Z. Then this, after this line, we have to take whether this loop would become 0 or not. So we are giving here the loop 2 label, and this label would go to this line. That is the, so in this way, we have to calculate the total number of t states using the nested for loop. We have calculated for this inner loop that may be 1572847. So the concept is same. How we can calculate the number of t states for both of the loops. Again, it will take the 10 t states and it would take the 60 states. It will take the 40 state and it will again take the 40 states and it will take the 10 or 70 state, which we have already discussed. If we have to find a delay, like if we have to find a delay, that is total t states is equivalent to total t states is equivalent to number of t states inside the loop, number of t states inside the loop plus number of t states outside the loop. Outside the loop. So we have discussed like this way. We discussed number of t states inside the loop. Like in this case, how many number of t states for this example? Like we have 1572847, and after that these number of t states inside the loops. So how we can write here? Like if you have previous one, we have 157, that is inner loop, 1572847. Then in the inner loop, we have DCX statement, then that may contain plus 60 states. Then after that, we have move instruction that may take 40 state, then OR instruction that may take again 40 state, then JNZ, we have 10 T states. Then this number should be multiplied by the decimal value of the outer loop counter. Then this value 3 time would be less because 1 time 3 time loop would be executed less. Then after that, outer loop have the 10 t states. So these are the number of t states required for using total t states. So we have to calculate this value. This value may be approximately 1030781000992 approximately. So that number of t states are required if maximum delay we are using as a resistor pair. But if your frequency, operating frequency is, for example, if your operating frequency is 1 megahertz, so T may be 1 microsecond, and this is the time. If you convert it into the microsecond, 0781000992 microsecond would be required to execute this cycle. Either you can convert it into the second by doing it like, suppose these 5 values, you can write here 10307.8.100992 second time is required to execute this concept. Thank you for watching this video.